हेलो 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 व्हाट्सअप। भाई तू आ जाएगा, नंगा आ जाएगा, रुक जा, स्ट्रीम चल रहा है, लाइव स्ट्रीम चल रहा है। देख कोई देखेगा नहीं, लेकिन फिर वीडियो तो रहेंगे। पूछने तो जैसे क्या ही हुआ। ओके ओके यो What's up everybody, so we are back. So now we are going to solve some questions from Microsoft. Yeah, so we have this question. Okay, क्वेश्चन का नाम है कंटेनर विथ मोस्ट वाटर. बेसिकली माइक्रोसॉफ्ट, गूगल, अमेजोन, एडोबी, ब्लूमबर्ग में आया हुआ है लास्ट 6 months में. ठीक है, सो एंड बाकी एप्पल वगैरह में 6 to 1 year के बीच में आया हुआ है, और बहुत सारे कंपनीज में पूछा गया ये क्वेश्चन. लेट्स गेट started. Okay, देखते हैं, लेट्स सॉल्व इट. और ऑनेस्टली बोलूँ तो इसको मैंने सॉल्व किया नहीं है, लेकिन आई गेस सिमिलर काइंड ऑफ प्रॉब्लम मैंने देखा हुआ है पहले. सो या टाइमर सेट कर देते हैं एंड लेट्स स्टार्ट. ओके, so you are given an integer height of length n. There are n vertical lines such that the two endpoints I and the I, okay, line are I0 and I comma height I. There are n vertical lines. अच्छा ठीक है, we have n vertical lines. Two endpoints of the ith line are I comma 0 and I comma height. Okay, so two endpoints I comma 0 and I comma height. Find the two lines that together with the x-axis form a container such that the container contains the most water. Okay, so I want to find the container with most water. Okay, ये question. Okay, find the two lines. What does this basically means? Find the two lines that together with the x-axis form a container such that container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, we cannot slant the container. Let's look at a test case. So we have something like 1, 8. Okay, these are the heights. Now in this case the maximum area of the water is 49. Okay, so we have height 7 here, and okay, maximum we can store is 7, and we have 8 here. So between 8 and 7, what is the maximum we can store? It's 7 7 is 49. Okay, okay, okay. So what we basically need to do is that we have to select two lines. Okay, and we have to make a container out of this. Let's say I select this red line, these two red lines, so this will make a container boundary, and obviously the amount of water will be the maximum amount of height the water can reach is the minimum among these two, right? And that is 7, and the distance, which is the base, has a length 7 as well. So 7 into 7 is 49. So I have to return this maximum area, basically this area. Okay. Okay, so let's write down some key observations. Okay, so we'll say observations and approach. Okay, so um we need, okay, the main thing is that select any two what lines, and such that area of water is maximum, right? This is the main crux of the problem, right? How do we select? Okay, so if we think in the brute force way, the approach is will be very simple. We will select all the possible combinations of selecting two lines out of how many lines? N lines. Okay, so the range is for n here is obviously the constraints are n is less than equals to 1 to the power 10 to the power 5, so that is very large. So obviously when we select 2 out of n, that would be nc2, that would be order of n square. Okay, so that won't work, the brute force solution won't work, and we have to optimize it. Okay, and talking about the height, we have 10 to the power 4, so at max it can go up to 10 to the power 4 and into 10 to the power 4, because the length, okay, so n is equal to height dot length. Okay, and n, okay, so the result should be inside int, because the max it can go is 10 to the power 5, the base length, and the max height is 10 to the power 4, so 10 to the power 9. It can be stored inside integer variable without overflow issue. Okay, so the constraints are properly understood. Now let's, obviously we thought about a brute force approach, right? Now let's try to optimize the approach. Okay, so let's take this test case as an example. Okay, so I am starting from here, right? So it's 1. Okay, okay, it's 1. Now I have 8, so should I make this 8? Should I include this 8? If I include this 8, obviously I will get a volume of sorry, area of 8, right? Sorry, 1, right? What if I do here? Then I will get obviously 2 into 1, the area will be 2, and now the area will be 1 to 3 into 1, 3. Okay, okay, let's say I am at 8 and I want to know what is the maximum that I can get from 8. Okay, okay, though, so the main issue is that, okay, let's say I have I pointer at A. Okay, and I said, okay, so I selected 6, so what will be the um, what will be the length, base length will be 1, and the height will be minimum of both, that will be 6, right? Now should I go with should I increase this, because I don't know, right? The 2 will be good, it will increase the result, or it will decrease the result, because the base is increasing but obviously the height is decreasing, right? So we need to try this as well. And yeah, obviously we found that this is not working, because it's the minimum is 2 and the length is 2, so it is 4. Now we'll go, obviously we don't know. Instead doing that, can we let's see if we can think maybe in terms of stacks. Can we think it in terms of stack? I have 8. Okay, I want to find the maximum area, right? So I want to find the maximum area. I'm getting one approach in my mind, is that since we just to since we don't know the height, right, which we are talking about, we don't know what will be the minimum height of the container or the maximum height of the container, that will give us the best result, right? And the possible values of height will be one among this, right? It can be either 1 or 8, like in this case we have height 7, the minimum height 7. So if we somehow know that, let's say we are at position 2 and we want to check for 2, so what we will do is that I'm checking for height 2. I will check what is the rightmost, basically, what is the rightmost number which is greater than 2, and I also want to check what is the leftmost number which is greater than or equal to 2. So in that case I have 8, and here I have 7. So yeah, so I can make a height, at least I can make height 2. I can make a container of height 2, right? And I will check what is the amount of water stored there. I can do this, right? So and similarly we can do that for height 8, height 6, and check for all the possible heights and return the maximum among them, right? Now the issue is that, how do we calculate the maximum? How do I know what is the index at which it is present, right? So for 2 I want to find the largest element to the rightmost element that is larger than or equal to 2. Okay, so can we do it like using stack, maybe using some something similar to next greater element, just bombarding the ideas. Can we think? Okay, so we are at 2. Now we need to pre-compute it, right, so that we can use it in O of 1. So for 2, instead of next greater element, I want, okay, let's say I am at 2, right? So for 2 I need to start checking from 7, right? So I'll say okay, 7 is greater than 2. Okay, let's start from, okay, obviously I can run it maybe from 2. I can just run a loop, but that would increase the time complexity to O of n square again. So instead of doing that, let's just think for 2 minutes that if we can go with this approach, otherwise we need to change the approach, right? Okay, so let's say we are at 1 and we need to find the rightmost element which is greater than or equal to 1, right? Okay, so um so 1, so I'll have 8. Obviously 8 is greater than, so I know that for index for 1, I know that 1 is the answer. Now, so I'll just add 8 here. Now I'll go with 6. 6 is obviously smaller than 8. Okay, maybe I need to have it in increasing order. Okay, I need to find the next, if I find the next smaller element, would it work? It won't work, right? Because I I don't care about smaller elements. I only care about the larger elements, right? So let's say if I start to check from the end, for 1 I know the 7 is largest, so answer should be 1 2 3. Okay, so let's just put 7. Now for 8 I know 7 is smaller, so I'll just keep going. So 3 8, yeah, so it is, so I'll just put 3 here. Now for 6 I can't go back to 7, right? So I need to somehow know. Okay, so maybe I can start from the back. or I don't know. What is the largest element? It's 8, and 8 is here. Then I will go for 7. Or else I can just go from here. So I'll say for 7, anything for 7, I'll just say it's the last position, right? 0 1 2 3 4 5 6 7 8. So I'll say it's at 8. And for 3, it's at 7. Then I'll say for 8, it's at okay. So for 3, okay, it's not at 7, right? I already have something larger than 3. So if I have something larger than 3, then that means that I should sort it on the basis of index. Okay, index and values. Maybe I can store a pair and sort it, something like, let's say, I know I have 7, right? So 7, and I know 0 1 2 3 4 5 6 7 8 is at 8th position, and I have 3, so I'll just say my 3 is at which position? 3 is at 3 is at, let's say, so let's say we have 3, right? And what's the index for 3? We can say, okay, 6. Then we have 8, so we'll just put 8 here, and 8 has an index of 5. Let's now we'll go for 4. Now 4 has an index, so 4 will be here with index 4. Then we'll have 2. 2 will be here with index 3. Then 6 will be, where is my 6? 6 will be here with index 2. Then 8 will be here with index 1. Then 1 will be here with index 0, right? Okay, so let's say we created this array. Maybe we can do this by using pair and sorting it on the basis of the first values. Okay, now if we know this, okay, now what we need to do is that we need to search. Okay, let's say I am at I want to go for 8. So for 8 I want to search what is the maximum value of 8. So I can search it and I will find that 5 is the maximum. And what is the minimum for 8? Okay, I can go for exact 8, or I can go for a number that is greater than 8. Okay, yeah, whatever it is. Let's say we want for 7. Okay, so for 7 I know uh, I want something greater than 7, so I'll have 8 comma 5, which is the, and I want a lower bound. I want to search a number which is less than, which is greater than or equal to 7. So I will have 8, search for a number which is greater than or equal to 7. So I have 7, I'll have 7, 8, but here, right, I want to select 8 out of this, right, which can't be possible, right? Obviously, search it 7, I'll get 7 comma 8 to search leftmost. So if I search for upper bound, obviously it won't be possible because 5. Okay, so yeah, so this approach is very vague. We can't solve this. Okay, so let's try to change the approach. We want to calculate the maximum area, right? Okay, it's tough.
Hi guys, welcome to a very
Ah, let's see if we can do something here. Okay, how can I do that? Let's say I'm starting from here. I know this one is bigger, so I will keep the smaller one, right? So because I know that the leftmost limit is here, so I know the length as well. It's okay if this one is greater, then that's fine. Okay, now I know that I have one which is a height 1, and I know I have a variable which is height 8. Now when I am at 6, I'll have two choices. Should I merge it with 8 or should I merge it with 1, right? That's the two choices I have. Since it's 1, for 1 I know for minimum what it is, right? If I go with 8, I also know the index, so I know that it will go. Okay, so now when I'm at 186, for this two I should So here one thing is there is that uh, 8 is obviously larger than 6, right? 8 is obviously larger than 6 and 8. So should I include 6? No, I don't need to include 6 because I have 8 which is already larger than 6, and let's say it has a value something like 8 comma whatever the index is 1, and obviously I want to insert something like 6 comma 2. Is it necessary? I already have 8 comma 1, so should I include this? Obviously no, so I don't need to include this. And only one thing I need to concern about is that I have 1 comma 0. That's it, right? Now let's say I went to 2 now. Okay, so for 2 I should either check with this or I should check with this, right? And the thing is it's 2 comma 2 comma 3, right? So now what should I do with this? Should I should I keep this information that I encountered 2 comma 3, or I should discard this? Okay, so 2 comma 3 says that at index 3 we have a height, we have tower of height or whatever it is, pillar of height 2. Obviously should I use this? No. Instead 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 of using this doesn't make any sense. Before it I have a larger one, so unless I will get something larger, then it doesn't make sense. Okay, let's say 2 comma 3. So now 8 comma 1, right? Now 2 comma 3. After that I'll have something like we have 2 comma 3, then I'll have 5 comma 4. Now let's talk about this. Should I include 5 comma 4? No, I already have a larger, so no need to include this. I should just ignore. Then I will have 8 comma whatever it is, 6. Just ignore it. Obviously I have pillar of same size already, and it is more in the left side than the current one, so obviously I don't need to include this. Then obviously I'll get 3 as well, don't need to include this. Then I'll get 7, don't need to do this, but I'll need to check, right? Let's say now the issue it's not when we get a decreasing, okay, something like I get 1 point, which is that if I have something like, let's say instead of these, let's say I have something like 3 and 6 and 1, it's increased. Okay, and we have 6, then we have 2, 5, and these all are smaller, right? When these all are smaller, I don't need to care because I already have the largest one. Okay, larger one. uh, m- just give me a moment. More on the left side, so I need not care about them, right? So let's say I have 6, so when I encounter 2, I don't need to care about 2 because I have already 6, a larger pillar, and more on left side. So yeah, and 5 also I need to ignore 4. But when I get 8, right, this here the things get interesting. So let's have this test case. So I have 1, right? So I know that I have a pillar at index 0, let's say, of size 1. Now after that, I know that I have a pillar which is greater than the initial pillar at index 1 of height 3. So okay, so when I get a new pillar, I don't know, should I make it this because it has a larger height, or should I go with this because it is more far further, right? So yeah, that's an issue. And again, let's say I have something like 6 comma 3. Okay, my bad, it's 2 comma 6. Okay, just give me a moment. The question is interesting. Okay, so we have 2 comma 6, right? Okay, now this basically means that at index 2 we have a tower of size 6 or pillar of size 6. So when we encounter some pillar after this, let's say, so is it required to check from the area from all this pillar, or can I go with something else? Let's say after this, okay, let's say after this, let's say this is inside some maybe stack or something else. So let's say after this we get a variable at index 3, let's say, that has a size 5, right? So now I need to calculate the area, the maximum area that is possible with this pillar as the rightmost pillar. So obviously I will go with this. It is possible. I will check, is it possible with this 1 comma 3? Obviously it is not possible, right? It is not possible. So what I'll do is that, let's say I will pop this out here just for a second. Okay, so now I'll check, is it possible? Obviously so for this height, what is the maximum volume, right? I can go with this. Then I will select the minimum height. Selecting the minimum height, I can so which basically means that I will just go on, right? I will just remove this, so that will cost me n, right? So the main issue is, if let's say if it's increasing, let's say I get let's say I get 3,7. so yeah, so what is the maximum area that is possible here, right? I don't know. With this pillar at the rightmost, I need to check for all. So in the worst case, that would be order of n square. I need to check if 2,6 is correct or not, whatever it is. Okay, I need to check, right? I need to check if it is possible or not. I don't know. It's getting tough. It's getting tough. For rightmost pillar of height 7. Okay, so one thing which I guess we can do is that, let's say we get 3,7, right? And if I want to check for 3,7, I will need to check for each and every one, right? And yeah, and instead of doing that, and let's say after 3,7 we get something like, at the index 4 we have something like 6. So instead of checking this, obviously this is the more optimal solution, right? Since this is smaller. So what I'll do is that whenever I get 7, I'll just pop it out. Okay, that's fine. Now again, let's say I again get something even more smaller. Let's say I get 5. So instead of checking with 4,6, I'll check here, then I'll check here, then I'll check here. Instead of doing that, I will check with 5,6. Obviously I'll directly check and update. I will just check till it becomes greater or equal, right? Let's say 5,5. okay, yeah, so I'll just remove it. Yeah, so again I'll remove it. So yeah, something like this. And let's say I again get something larger. So let's say I get something bigger. Let's say 6. At index 6 I have 8, let's say. So whenever I get something larger, whenever I get something larger, how do I check if this is the rightmost pillar? Obviously I need to check with this. And I need to check with this. Is it? I don't know. So if it's increasing, I don't know, it's confusing. Okay, so let's say we have something like 136, it is increasing. Then we have something like 6 5 4, which is decreasing. Just this. Okay, 3 6 5 4 3. Just 1 second. Just a call from friend. So let's see if we can do that. Do anything else. It's so tough, man. So let's say at index 0 I have 1, then I found at index 2 1, I found 3. So at index, okay, so I know that there is a smaller smaller pillar present. So yeah, I don't know which one can work, right? Okay, and now let's say there is one more, 6. So obviously there is a larger pillar, so I don't know which will work. Now let's say Now I got something like 5. Okay, so at index 3 I got 5. So now in this case I know that this is a smaller pillar as compared to this one, right? So I know that for all these pillars the pillar's height is smaller than this pillar, right? So instead of going with this, I would like to check with this, right? Yeah, now it's correct. Yeah, that is the crux. Now I guess it should be solved. So the thing is that okay, now let's move on. Now 3 5. Okay, now we'll have at the index 4 we have 4, right? So I know that all these pillars are less than this, right? And instead of checking with this, I know this is more further away, so I should check with this. Okay, now let's say I have 3 comma 3. Okay, I know that all these pillars are less, so instead of checking with this and all this, I should firstly take this and I'll just calculate and put it in the relay. Then I should go and I should check with this, right? So I'll say okay. Okay, now both are equal. Oh, I know instead of checking with this I should check with this. Yeah, that's it, and this will give me the required answer. So the approach will be start with the okay. So what I'll do is that I will iterate the array and add index comma height to the stack. Okay, and stack will be increasing stack. Okay, that's it. I can say yeah, increasing. So observation is that smaller heights. Okay, so I can say that the further the pillar of size. Okay, observation is that I can't, how do I say the observation? The main thing is that let's say we have a stack with, let's say we have something like 1 3 4 5 and we get something like 3. So taking making okay, taking new smaller pillar as the rightmost pillar is more optimal. This is the crux. I can say since it is further, i.e. it will become something like 1 2 3, right? Okay, so another more important observation is that why I am keeping the increasing stack, right? So I'll say Okay, but won't there be issue? Okay, so if I say I don't know, man. इसमें भी इश्यू लग रहा है अब मेरे को. इसमें भी इश्यू लग रहा है अब मेरे को. I'm tired, यार. This observation is correct, but there is an bug in this observation is that, let's say I get 1 3 6 right, and I get 4. What if I get now 8 again? So with this 8, so my array will be something like whatever stack, let's call it stack, will be something like 1 3, right? And I have 8. So I can check this, I can check this, but with this 8 I can't check 6, right? 8 6 combo, which could be potentially larger. I can't. This is a larger 6, and if I have 5, instead of checking with 6 I should check with 5. So I'll say okay, 5 6 is checked. So this is the array. It's maximum which I can get from. Okay. 5 6. Back Salah. I just don't know, man, what to do, 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 what to do. What the fuck is this? What the fuck is this? I just can't get the vibe. Okay, so I'll just go move on. Okay. Degree thing I want to know. Okay. It decreases and decreases. reaches since this one is larger. Should I go with the decreasing stack? I don't know. Okay, so I'm saying it. If I say that this is okay, this is okay, since 1 unit length. Mathematically. Three. For 4. Let's see here go. We do something like 7 area. Degree stack. Or 7. नहीं आ रहा